Okie dokie, so this section of notes actually starts on the previous page, but I forgot to put that on this video. So flip back a page to page 29, and this is something called logarithmic differentiation. This is the last piece to being able to find the derivative to any function, because up until now you've had either a variable to a constant, in which case you would use the power rule. You've had a constant to a variable, in which case you would use the exponential differentiation. And now we're going to look at what happens when you have a variable piece raised to another variable piece. So that process is called logarithmic differentiation. So if you flip back to page 29, the first thing you're going to do is take the logarithm of both sides, and then you are going to differentiate and go from there. So it makes more sense if we go ahead and look at an example. So flip back to page 30 and take a look at example 9. Find dy dx if y equals x raised to the x. So variable raised to a variable piece. So you don't start off by just taking the derivative of this. You start off by taking the log of both sides. And we're going to use the natural log. So when you take the natural log of both sides, you'll have the natural log of x raised to the x. Now you have to go back and think about some of your logarithm rules from previous courses. And when you have an argument of a logarithm that is being raised to an exponent, you are allowed to bring that down to the front as a, I don't want to say coefficient, but it gets multiplied to the front. So you'll have the natural log of y equals x times the natural log of x. So I haven't done any calculus yet. I'm just kind of doing this to help me get the variable out of the exponent. Now you can take the derivative of both sides, and we're going to have to do it implicitly since we have y as a function of x here. So, and we're using the rule that we learned just recently, the derivative of a natural log. So the derivative of a natural log is the derivative of the argument. So the derivative of y is dy dx. That looks kind of silly. Let's fix that guy. Okay. dy dx divided by the original argument, so that's the y, equals, and on the right hand side, if you see it says x times the natural log of x, you're going to have to do the product rule. Product rule says the first times the derivative of the second, and to do the derivative of the natural log of anything, it's the derivative of the argument, so that's 1, divided by the original argument. That's going to be x. And first times the derivative of the second plus the second times the derivative of the first. And in this case, again, it's just 1. We can clean up the right-hand side a little bit, but before I do that, I'm going to multiply this y here. I'm going to multiply that to the other side to get it out of the denominator, because the end goal is to solve for dy dx. So I'm going to have dy dx equals y times, I'll have x times 1 over x. So that's just going to cancel to 1, plus the natural log of x. And the final piece in here is that I can actually substitute this y right here with this quantity up there. Okay, so I know I'm drawing lots of little lines here. Okay, but I know what y stands for. Y is really x to the x. So I'm going to substitute that back in place, and then we'll have the derivative in terms of only x. So it'll be x to the x times 1 plus the natural log of x. And that's it. That would be the derivative. Okay. I would like for you to try example 10 on your own. So press pause and then come on back. Did you try it? Really? All right. Here we go then. First thing first, take the natural log of both sides. So it will say the natural log of y equals the natural log of the sine of x raised to the cosine of x. And again, because we have that's the whole purpose of taking the log of both sides, because we have the argument of a logarithm has an exponent, and we can bring that down to the front. Again, we haven't done any calculus yet. That's going to be the cosine of x times the natural log of the sine of x. Please remember that it's the natural log of the sine of x and not natural log times. Natural log needs an argument. Now we're going to go ahead and take the derivative implicitly of both sides. In the previous example, we showed that the derivative of the natural log of y is just the derivative of the argument divided by the original argument. And I'm going to press pause because I hear my son coming upstairs. Hold on. Okay, so we've got a product rule on the right-hand side. We've got the cosine of x times the natural log of the sine of x. So the derivative is going to be the first cosine of x times the derivative of the second. So first times the derivative of the second. And this is a little bit different here. We've got the natural log of the sine of x. So the derivative of the natural log of anything is just the derivative of the argument. So the derivative of the sine of x is cosine of x all over the original argument, and that's going to be the sine of x. So first times the derivative of the second, now we go plus the second natural log of the sine of x times the derivative of the first, and the derivative of the cosine of x is the negative sine of x. All right. We can clean this up kind of just a little bit, actually, not too much. We'll have dy dx. We're going to multiply that y over again. And here you can write cosine of x times cosine of x over the sine of x is going to be the cotangent of x. And actually, I suppose we can go ahead and move the sine of x in front of that. And it's negative, so minus the sine of x times the natural log of the sine of x. And again, just like we did in the previous example, we know what y is. It's the sine of x raised to the cosine of x. So this is not the prettiest derivative ever. But come on, they can't all be pretty. So we'll have this minus the sine of x times the natural log of the sine of x. And that, my friends, is the derivative of the sine of x to the cosine of x. So I hope you have enjoyed this lovely lesson, and I will see you tomorrow.